we are discussing about wire bond. So what is wire bond? Wire bond is to connect the die to the lead frame or to the GOB or to the substrate, so that the connection has to be very good because of the transferring the circuit on the chip to the lead frame or the GOB. So what we need? So we need the free air wall on the first board. So this free air wall created by the AFO, the electronic flame off, so that the wire, it will be melt and creating ball, and this ball, it will be connecting to the first ball on the bond pad of the die. So this will be very critical because to generate the intermetallic between the die and the wire. So this one using the thermosonic process. So next, after the ball completed, so this will be transferring the wire to the wedge of second bond. So this second bond, it will be goes to the lead or to the pad of the substrate or the lead frame, so that this will be creating the wedge area. So this process is very critical because of the contamination of the pad. It will be create the non-stick. So this have to be a very clean surface. So this is the one that we have to understand about the wire bond. And also there is a bump process. So the bump process is something like we put the ball only on top of the die or on top of the wedge. So this bump is to make the bonding from die to die, so that because the die second bond is not possible to the die, so it's possible when we do a bumping. So this we call it ball bump. So this will be can see on the actual practice later on. Next is the wire. So what is the wire? Wire, normally we are using gold or copper. So gold, there is several gold that we can use. It depends on the purity. So there is 2N wire or 4N wire. So 2N wire is 99% and 4N wire is 99.99%. So this depend on the application, also depend on the reliability required. And there is also the we call it copper bonding. This copper bonding, we are using the copper wire, and this copper have to be there is a technology to make the coating on the copper wire, like palladium coating or something else. So it depends on the technology. So this copper wire, it will be very cheap compared to the gold, and the reliability is comparable, we can see. So that this gold wire and copper wire normally is used for the semiconductor. And next is the bond pad. So what is the bond pad? So bond pad is the area to make the first bond, because of this connection goes to the lid of the lead frame or pad on the substrate or COB. So this pad is normally used LC2, this aluminum silicon copper, or maybe there is also gold flash or something. So this it depends on the technology of the wafer. So we can see that also pad, sometimes also there is a circuit under pad. So because the chip is very small and they don't have area, so that they have to put the circuit under pad. So this is also critical during wire bonding process. So we have to be make the good parameters to this process. Next is the wire bond pad. So this wire bond pad, if you can see, is quite many layers. So that this layer can create a good adhesion or good stronger pad to make bonding or to make the connection to the electricity to the lead frame or COB or substrate. So that's the bond pad. Next is the free air wall. So what is the free air wall for the first bond process? So free air wall is something like the to create the ball on the first bond. So when you have a very small pad, so the free air ball has to be small. And if the bond pad is big, so the free air ball has to be bigger. So this is very critical when we do a free air ball because there is a heat zone area. So this heat zone area is very brittle. So that's why sometimes we need to check the wire pull. Where is the breaking mode on the wire pull process. So this one is a free air ball. Next is the capillary. So what is the capillary? So wire bonding process, we need capillary to bring or to carry the wire from the first bond to the second bond. So this capillary is quite many types. So it depends on the application also. And also this creating also the ball size. It depends on some customer, they really control the ball size, or we call it ball aspect ratio. So they control the diameter of the ball and the thickness of the ball. So this will generate how strong is the ball on the first ball. So this we call it we using a capillary to create this. So next is the wedge. So wedge is the connecting the second bond to the lead frame or to the COB. So this wedge is also critical because this only putting the wire to the surface. So when we have the second bond, so make sure also there is no crack or there is no contamination, because small contamination it be very bad to the quality of the wax. Next is the dome holder. So this dome holder also is important because why? This dome holder is giving the heat on the wire bond area. So that because the wire bond process is a thermosonic, so heat and ultrasonic frequency on the capillary. So this heater block or dome holder will give the heat to the lead frame and the die during bonding, so that the process it will be very good and optimized depending on the design of the dome holder or the heater block. Okay, next is the ball bond. So ball bonding, there is an intermetallic, or we call it IMC. So we have to control also this intermetallic because it's too big, it's not good, and too low is also not good. So we normally control in the 60% so that the adhesion or between the bond pad and wire is better, so that we control also the MC. So too big also is not good because influence the relative performance.